In this video, I'm going to look at converting a floating point number to a decimal number. So here is my example that I'm going to work with. So first of all, the sign bit is a 1, so it's going to be a negative number. So sometimes some people will say -1 raised to the sign, so -1 raised to the 1 is -1, or you can just sort of flat out just say, I know it's going to be a negative number. Okay. Then the exponent is sort of listed first, so let's deal with it first. So I'm going to take the exponent, I'm going to figure out what it is in binary, and then I'm going to unbias it. I'm going to subtract 127 from it. So the exponent here, I'm starting in floating point representation, so I'm in binary, and my exponent was 0, 0, 1, 1, 1, 0, 0, 1. Okay, so that was 57. So I'm taking the 57, and then I'm going to unbias it. I'm going to subtract 127. And that's going to be -70. And that's going to be my power of 2 when I'm ready to put all the parts together at the end. Okay. So then next thing I'm going to do, clear that out, and I'm going to deal with the mantissa next. So when in floating point numbers, there is a 1 at the beginning that you do not store. So I have like 23 bits here stored, but I've got to sort of bring back the 1 that I didn't bother with. But now that I'm trying to figure out what the number is, I need to bring it back. So I'm going to put myself in binary mode. I'm going to enter this mantissa, starting with that 1 that you don't see, but needs to be sort of brought out. So I bring it out of storage and add a 1 at the front. So 1, 0, 1, 1, 0, 1, 1, 0, 1, 1, 0, 1, 1, 0, 1, 1, 0, 1, 1, 0, 1, 1, 0, 1. Try to make my life a little easier and give myself a bit of a pattern there. And I can see here in the binary, I have 1, 2, 3, 4, 5, 6 groupings, 4-digit groupings. That's 24. And that's what I'm expecting. There were 23 stored, and I added a 1 out front. And so I should have a binary of 24. I am going to take that. So let me display some steps here. So I'm taking the mantissa with the stored 1, and then I'm going to convert it to decimal. There's that. And then the next step I'm going to do is take that, and I'm going to divide by 2 to the 23. So I'm going to take that over to scientific mode. And Control V, paste that back in, and divide it by 2 raised to the 23. And I get a number between 1 and 2. So remember that this mantissa, once I've restored the 1, is like 1 dot. So I expect the number to be more than 1. And then that first thing after that dot, that first 0 is the halves place. So I expect it to be, in this particular case, less than 1.5. But in general, I expect a number more than 1 and less than 2 from what I just did. Now I just put the pieces together. So overall, it was a negative number, so I'll put that in. Then I'm going to put in this number between 1 and 2 that I just got. Put that in there, and then I'm going to multiply it. I'll just use an asterisk times 2 raised to the, this is -70, so I'll use parentheses there, -70. And then I want to figure out that. I want to like do that calculation and get it into some kind of decimal or scientific notation will do. And for that, I think I will just use Google as a calculator. So Google, if you give something a calculation, Google's not going to look it up. Google's going to do the calculation. So there it is, a minus. So that's just, how am I going to grab that? There we go. And so I will say Control V. So it was minus 1.21 something something times 10 to the minus 21. And I'll just say from Google. You can do it on a calculator if you want. Okay, so that is my answer. And now let's try to check. I'm going to use this online floating point calculator here. Let me clear out. That was some previous thing I was playing with. And now let me go to the original. Let me squeeze this a bit. Okay. And it was, the sign bit was a 1. The exponent was 0, 0, 1, 1, 1, 0, 0, 1. And then the mantissa was 0, 1, 1, 0, 1, 1. Nice repeating pattern. So I make fewer mistakes than I usually make here. Doesn't help when they all of a sudden it takes a different amount of size. Okay, so that was my pattern, 0, 1, 1, 0, 1, 1, 0, 1, 1. There it is. And so when I put it into the online floating point calculator, I'm getting minus 1.21004 something something. E is times 10 to the minus 21. And that's what I was getting out of the Google calculation. But I wanted to show these sort of in between steps. So I just didn't want to use the calculator, but I wanted to see the exponent, how it relates to a power of 2. So you get the number, you unbias it. That's a power of 2. In this case was negative 70. How the mantissa bring back the stored 1 and then get a number between 1 and 2 and so on. So that's what I wanted to show you. Thanks for your attention.